FRQ into your calculator, and then we'll get ready to go. I won't hit record here for a little bit.
Is it in the uranium mode?
Yes.
Okay, mine isn't that.
I just have to wipe mine out from last hour. And alright. So I'm going to start recording here in just a second. So if you guys could be... I'm going to take my gum out. Alright guys, I'm going to record, so be quiet. Number 2, FRQ, it is calculator active, so go ahead and load those 2 functions into your... Alright, so for warm-ups today, we're doing in the bright green packet, we're heading into the FRQs. We're going to do a calculator active particle motion. If I were to pick the top 6 things that you'll probably be FRQ'd on, because you do 6 FRQs on the AP exam, particle motion would be in that. So most likely you're going to get one. Not every year, but most years there's a particle motion. It's almost always calculator active. This one has 2 interesting questions in it that you haven't seen before, so that's going to be kind of neat. But for letter A, we're on the interval from 0 to 5, so you should have your window on your calculator set to go from 0 to 5. You should enter the velocity, and we don't all have to enter it on our calculators. If enough of you do, just so I can get some answers, that would be great. I know you know how to work the calculators now, so more importantly is the setup. So we want to know when the velocity of the particle is decreasing. A function is decreasing when its derivative is negative. So when the derivative of velocity is negative, that's when the velocity function is decreasing. But that means we're going to look at our acceleration function. So you're going to look at the second one you graphed, the acceleration, and you're going to find out where it is negative. Okay? Last hour, I remembered that it was from 0 to something and 3 point, but I don't remember the decimal places. So if somebody could calculate that second 0, what is it, Ray?
3.07.
We should go to 3 decimal places.
Well, it's 7-0.
7-0. Okay, just to make sure. You have to be accurate to 3. So, so that one's done. That one was very straightforward. This second one, as I read the problem, I kind of knew that I was going to have a question where they're going to ask me what the position is, either before this time or after this time. But because they gave me it at time 0, it means they're going to ask me what the position is some other time. And it's right here. Find the position of particle P. So the position of particle P at time 1 is going to equal where it was at the start. And you don't need the little p's on there. I'm just putting it on there because I know that on the next page when you flip it, we're going to have particle Q as well. So that's kind of why I'm putting that on there. But I know I have to take into account where I was at the start, which was actually, did it say at 3, guys? Does it say it's at 3? Thank you. So it was already 3 to the right before it even started moving. And then I'm going to see how much it was displaced from 0 to 3. So all I really need you guys to do is hop on your calculators, and you need to do 3 plus and then math 9, that guy, and it'll give us our position at time 1. And again, I just need at least a couple people to agree. What do you have, Shannon?
That's supposed to be a monoton.
Yes. Thank you. Thank you, thank you. Definitely. So at time 1, where were we? How far did we move? That'll tell us where we are after the move.
4.778.
4 point. Do you have a background of this? Yep. Okay, perfect. So we'll just move along to the next question. It's an interesting one because you've never been asked about this topic in a particle motion problem, but I had them read it last hour, and I said, just blurt if you know what topic this is, and Wanzer blurted, and it was right. So go ahead and read it, and see if you know what topic this is testing. There's a couple trigger words in here. This must be a time, and you're trying to guarantee the existence of something. And we only have 3 things that do that, and only 2 do we really use much. You just said the MVT and the IVT, yeah. So whenever you see that, where you have to prove that there's the existence of something, it's either the IVT or the MVT. The MVT is about derivatives. The IVT is about y values. So when I'm given position and it's asking me about velocity, that means I need to take the derivative, and it means this is the MVT. So you have to know what the MVT states. It says that there's got to be at least one place where the average rate of change, also known as the slope of the secant if you're doing a non-word problem, equals the instantaneous rate of change, also known as the slope of the tangent line if you're doing a non-word problem. But this is an actual, so I need my average velocity to equal my instantaneous velocity at least one place. Well, my average velocity would be change in position, which is 9 units, over change in time, which is 3 units. So maybe that was 9 feet in 3 seconds, and that's feet per second. That's my average, right? So this is equal to my instantaneous rate of change. So I do get the 3. So that wasn't really a shocker because it said there must be a time. So I knew I was going to get a 3 with that average rate of change. But I'm missing, this is a 2-point problem. And I'm missing some stuff that's going to have me lose 1 point. Anyone know what I'm missing? What was that? No, because I just had to explain why there must be a time when the IROC was 3. So I'm getting the point for that. I've got it existing, right? But with the MVT, there are some details that you needed to make sure you... The function is not only continuous, and differentiable. Yeah, so we're going to write that on here, that this function that we're doing the derivative of, the position function, we're going to have to say x of t is differentiable. I'm just going to write diffable, and therefore continuous. So you kind of have to make sure that you verify that the criteria has been hit. The IVT is just about how you have to hit every y value on your way, and you don't have to be differentiable. You can have cusps and stuff there. So this would say, then by the MVT, the velocity has to equal 3 at least once. I'll put at least once. So not hard math, but a lot of times when they kind of put the skills embedded in other skills, if you don't really understand, that makes those kind of difficult. I love this last question, actually. I'm going to need some calculator help, but it says now I'm at time 1 second in, and I've got these 2 particles. I've got particle P moving left and right, and particle Q moving left and right. They're just little particles zooming along the x-axis. It wants to know if they're moving towards each other and are going to crash, or if they're moving away from each other at time 1. There are 2 things I need to know to decide kind of if they're moving towards or away from each other. Do you know what one of them is? I need to know 2 things about particle P and 2 things about particle Q. I need to know their velocity and I need to know their position. Yeah, so I need to know the position of particle P at time 1, and I need to know the velocity of particle P at time 1. That was the first particle on the other page. So it means you can either calculate it, or it was given to you, or you already calculated it. So for the position at time 1, you gotta go back to particle P. I think you already told me it. I think 4 point, yeah, that was the one Carson gave me, 4 point. So what that means is on the x-axis, if this was 0, particle P at 1 second in, is at about between 4 and 5. Here's particle P sitting here. I need to know now if it's moving to the left or to the right. So now what do I have to look at? Its velocity. Where would be the quickest way for you to calculate that velocity? Go to your table. Yeah, go to your table and pluck off the velocity. I remember from last hour it was 1 point something. And I don't really need that because I know it's going this way, right? Now, if Q is over here going that way, they're going to crash. They're going towards each other. Now I have to look at particle Q and say, where are you, particle Q, at time 1? Okay. Now, I either have that given to me somewhere or I can find it. So I have to look at all my info about particle Q and see if I need some work or if I've already been told it. And I don't know because I lost the stem of the problem. But somewhere it's 2. Did they directly tell you
Said
it's
it in the sound problem.
It's in the stem of the problem. Perfect. So that's nice. The velocity at time 1 for particle Q.
That's from this question.
Where was it?
So the velocity of particles.
Oh, they gave it to me. -3 again. So they both handed to me. Thank you. So I know that one's over here at 2, but it's moving to the left. Now this can't be the answer to my question at all. Like, the readers they don't look at graphs, they don't look at drawings, they don't look at sign lines, none of that. Just the math and the explanation. So you're going to have to say they are moving what? Away from each other. Those little arrows do not cut it. You don't really have to explain that. Well, you might need to say, well, this one was to the right, moving right. This one was to the right, moving left. I'm not quite sure how explicit you have to be. I'll look at the scoring guidelines later. So that was done. First task for the day, done. Next task is to do one more. This class, I think we only missed one example yesterday. I had to do 2 in my 3rd hour. But you guys, the only one we haven't done is this fish one in here. And then when we're done, you can choose to either work on your own or in groups, just as long as you're working on the assignment the whole time. We did do the cake problem. Yeah, okay. So I think you guys, we just need to wrap it up with this one down here. So I want you off on the side here. When you're doing your worksheet, you're going to have 3 different kinds of growth models. So the first one is when the rate of change of the quantity is directly proportional to the amount present. That's our basic one. That's the one that gets used the most. It always passes off to knowing that exactly y is equal to c e to the kt. Kids tend to use that on all of them. So be careful. You can only use that when it's in that form, where the amount present is directly proportional to, we have a match here, it's not any addition or subtraction or anything like that. What was C in this scenario always? It made it really easy. It was the starting amount, right? So that was nice. Then yesterday we did Newton's law of cooling, which you don't need to memorize, so we'll just write it on the side here if you need it on your homework. That the rate that something cools is also directly proportional, but not to the temperature. It's to the difference between the temperature and the temperature of the surrounding environment or the surrounding medium. I can't tell you what T equals because it's a lot of work. I need to separate and integrate and find C and find K. There's no shortcuts to it. Okay? This is the 3rd kind over here. It's kind of like, looks like both of them, but it's different. So you have to just be careful. This one says that fish are being introduced into a man-made lake. So here's your lake. You've got fish. They're putting them in there. Okay? The rate of change in fish. So I'm going to start writing my problem. df dt. With respect to time is directly proportional. So there's my k. But it's not directly proportional to the amount of fish in the lake. If it was, off on to CE to the KT, but it's a difference between 900 and the number of fish in the lake. It then says, when t equals 0, there's 400, so that doesn't mean C is 400, because it's not that model, so be careful with that. And then it says 3 years later, after they stocked it, there's 600 fish in the lake, and I'm supposed to write the differential equation, which I did, and solve it. When it says to solve it, we should be really good at knowing that means what's the top variable, or what function will tell me how many fish there'll be, maybe a 20. Okay, so here we go. I'm going to separate 1 over 900 minus f, d capital F, is equal to k d small d. I'm going to integrate, and then I'm going to say, be very careful. So I want you to write down the antiderivative of 1 over 900 minus f. And who knows why I say be careful? The negative. Yeah, this isn't u prime over u. If it was 900 plus f, perfect. But it's negative 1 is what I get with the derivative. So that if you did the full out u sub, you would have a negative fraction correction. So there it is. And what do we say the antiderivative of k is? kt. Yeah, it's a constant, so whatever. And then plus c, and then we'll do what we always do. except you can't exponentiate until you get the e and the natural log like right next to each other. So you're going to have to get rid of that negative sign. Let's do that. So I have a negative kt plus c. Haven't found the c yet, so no need to negate it. This chapter should really start to be making sense about now. Is it? Like it does. Once you get to the work, that's what I love about this chapter is when it goes to application, you're like, oh, now I kind of get it. So now when I exponentiate, I have 900 minus f is equaling e to the negative kt, technically times e to the c, which has happened so much, I'm going to put the c right here. C is not 400, so be careful. Again, right now we are not doing this one, we're not doing this one. We're doing an alternative one, but I am going to let c absorb whether it's supposed to be positive or negative, so I can go ahead and take that off. Now when I solve it, I'm going to add the f over, so I'm going to put my f over here, add it over, and then I'd have 900 minus c e to the negative kt. Boom. It's not quite done yet, though. What's next? It's close, but it needs to be a function of time only. So I need Carl. Who comes first, Carl with a C or Carl with a K? Carl with a C, you're going to use this point. I mean, I would start shaving some time off of how long these take you and go, I would just think Carl out. I'd go, well, when t is 0, this is 1. I'd have to have 900 minus 500 to equal 400. So let's just go throw that in and save ourselves some time. Done. So for that, C is easy. The next C, you guys are going to have to help me out. I mean the K, you're going to have to figure out what time will, it's 600 fish after 900 minus 500 e to the negative, and then that took 3 years. So if you guys could go solve that on your calculator really quickly, or somebody, if you can tell me what the K is and I'll round it. But 600 minus 900, then divide it by negative 500, then natural log it, and then divide by negative 3, and just get, yep.
Why did you keep the negative when you brought the constant?
Where did I do something wrong?
So like when you brought c over the ce to negative kt, you kept the negative instead of the number the constant would absorb the negative.
I could make it, I'm just calling this a C, and whatever it is, if it's positive or negative, to move it over, I subtract.
Okay.
You know what I
The
mean?
negative wouldn't absorb?
No.
Okay.
No, you can just go ahead and work with it as it's assuming it's positive. You don't, it doesn't matter. It's not going to affect it. So when you throw it, it'll wash out as being like if you had put a plus, then when you found yours, you would have had it then. You know what I mean? It would have been the opposite. So it would work. Either way is fine. So that's not a great answer, but it works both ways. So go ahead and find the K by unwrapping this whole thing. If somebody could tell me what it is, it's going to be positive. I'm going to go to 3 decimal places. Anyone wrap it up? Point?
0.17. That's what I got.
Yes? All right. So there, I'm just going to put it there. You guys can go ahead and store it. I'm going to go point right here just so I don't have to do a rewrite. Now for part B, it says find the population in 3 years. So I'm looking for the amount of fish. So that's kind of nice because I'm just going to go take my model 900 minus 500 e to the negative 3 times my K, right? And I'd be good. You guys don't need to. I'm trying to sneak a little one in there. That's just running it through on your calculator, so I don't really care. I want to do the last part. All right? So watch this question. It's pretty common, actually, to throw a limit question onto these types of problems. So I'm going to go back to my fish model. 900 minus 500 e to the negative kt is equal to my fish, and that's my K, so I'm just going to point that at it. It says we're supposed to run this and send t on out to infinity, and then interpret what it means. And it's an and question, which means if you get the right limit but can't explain what it means, you won't get the point. So as t goes to infinity, 900 will not go anywhere, correct? I hate negative exponents. So what I'm going to do is rewrite it, especially when I'm working with limits. I'm going to rewrite it like that. So as time goes on out, or the years go to 20 years, 40 years, 50 years, 60 years, 900's not moving. What's this going to go to? As t goes to 1,000,000. 0. Yes. So my limit is 900. Now go back to the context of the problem. What do you think that 900 means in the context of this problem? It's the what? Carrying capacity. Yeah, the maximum amount of fish that lake can support. It will never go over 900 because it doesn't have enough resources, for lack of a better word. Does that make sense? All right, so we are going to quit, and you are going to go take out your packet. If you're absent, it's linked. You're going to be doing 1 through 10, but we're going to do number 1 together. All right, and then you can group up. Maybe no groups bigger than 4, but so. Oh, I didn't pass it out yet. That'd help, right? Here you go, 7.8. It's due tomorrow. Lots of calculator work on it.
I think it should be
No, I said no, before. And then tomorrow we start reviewing for the test. Your test is now what day? Tuesday. Yeah, it's going to be Monday, but I kind of. This would have been a long lesson Monday, so that's okay. All right, so we are going to do number 1 together.
Don't like calls the time this long.
Yeah, who calls you that?
Alright. So number 1 we're going to do together because it's not a real world problem. So sometimes, although it should make it easier, to be honest, in upper levels of math, the word problems I think become easier than the non-word problems. Like they make sense, like the amount of fish changing over time as I've stocked the lake. This is just y changing and I don't know what it is. But what I do need to recognize is that it's of the form dy dt equals some constant times y, correct? So really, this is dy dt equals kt. They've just handed me the k, which they've never done before. So it shouldn't screw you up though, it's actually easier. But we did practice one like this, but it's easier because you don't have to find k. Because it's of that form, you know it's y equals c e to the k, but they already handed it to me, so I don't need to spend time finding it. You'll see this happen often in multiple choice where they'll give you things for free, so it doesn't take so long, right? But what some kids who don't understand it will do is they'll be like, well, I don't know, they gave me a 2 here, I don't know what it's the k, they gave it to you. Also, they give you a nice little c in there, because what point did they say is on the graph? 0 what? 0, 1. Yeah, so that's nice. So remember, the start is always the c for this model. When I put in a 0, if I need to get a 1 out, c has to be 1. Now it told me I'm supposed to figure out what time we'll get it down to a half, which means I need to solve this for t, and I need to make sure that a half comes out for y. So now I need to know how to solve this. I'll go with whatever you guys tell me. That's what they said last hour, so I'm going to do that. I'll say natural log of a half is equal to negative 2t. And then I'm going to divide by negative 2. And then you're going to look and you're not going to see it. Okay? So you need to know enough. I don't know if it's algebra 2 or pre-calculus. Wherever you learn how to manipulate logarithms, you need to be confident enough to know your answer's right, but you're not seeing it, correct? You can't go to your calculator and see which decimals match up because you wouldn't have one. So you need to know how to play with this right here. There are 2 things you can do with it that'll lead you to one of those answers on there. So it's kind of like a 5/10 has not been made into a half. This is like the natural log of this. You can make it something else. 2 things, and they'll both get you the right answer. Anyone want to tell me how I can play with the natural log of 1 divided by 2? There's 2 things I can do. I could do that. I could say, well, I'm seeing 2 as the natural log in some of these answers, so I could go, thank you, I could do that. That's totally legal. I'm not seeing that answer either, but what are you supposed to remember from your natural log days? What can, yeah, the negative can come out front. So it's actually going to become a positive natural log of 2 over 2. And that one's sitting there, right? Somebody else, though, I just did that because Greta said it. Tell me another thing I could do with the natural log of 1 divided by the natural log of 2. What does division expand into? Subtraction. So I could say, well, it's actually the natural log of 1 minus the natural log. Because they're both legal, they're going to give me the same answer. What's the natural log of 1? Done. And there's my ln 2 over 2. So if you don't see your answer, play with it. And we're done. So your assignment is the rest of them. And you can work with a person, with a pair, with a triple. Go ahead, if you want to work by yourself, plug in your headphones because it's going to get a little loud. People working together.